Veeco Technologies Dektak 3030 Auto 2 Surface Profiler System. This system is equipped with a motorized stage which will move the substrate holder chuck in X and Y direction. There is a provision provided to have a sample held under vacuum, which isn't necessary. On this system, there is no auto theta option. It is possible to automate, but the system is not provided with auto theta ability. The system control is from this controller, which is interfaced to the main control unit here, and it has a dedicated parallel printer, OmniPrint 426. The system required to be powered up and warm up for at least 15 to 20 minutes. So I'm going to demonstrate from the power up sequence onwards. Before I proceed there, here is how the system menus look like. This is the first Dektak 3030 menu, and you have scan program menu here, and a number of programs can be written where the scan length can be changed. A typical program like this where we can have an ID for that, and a digit and number 1 to 9, and a scan length in millimeters or microns we can select. And then there's an auto leveling option, and there's a smoothing option, and the details are explained in the user's manual, where you can select the numbers in ratios of how much variation is allowed for the smoothing or auto leveling. And there are 3 options available for the speed control, that is the scan speed, which can be low, medium, or high. So typically for very small step heights, low speed is selected. And the profile, this system can profile various types of patterns, a trough, a crest, or a trough and crest both, which is normally chosen. And the measurement ranges are 65 kiloangstroms, 655 kiloangstroms, and then 1310 kiloangstroms, the maximum range. Also, there's an option available to select the display range, either auto or any specific values in kiloangstroms. The reference cursor and measurement cursor, these are 2 cursors on the profile which can be located on either sides of a step, such as this, which is a video image of a standard sample I have. Now, in order to profile a sample like this, it should be scanned all the way across the step, and then that way we can level it on the same plane, which I will explain in a few moments. And the stylus force is also selectable in milligrams. Currently it is selected 15 milligrams. So when you press button program again, we'll go to the main screen here. There's also a menu item called the key sequence menu, and if you say enter, now here in the key sequence menu we have also again sequence programs available which can be programmed. So here we can select various scan programs in this option, and then it's possible to also add an analytical function, such as one of these can be selected. For example, I just press video button to only display the graphics. So this monitor is a CRT monitor, and whereas we can select either graphics or video and graphics together. Now, at any point of time, no analytical function can be selected, or we can select maximum height, area, slope, average step height, circumference, and then average height, and then various other values, for example, maximum RA or maximum peak radius. So even the radius can be selected if it is not a step kind of profile. Typically, average step height is selected, so that's what I'm going to select. So you locate there and press enter, so you can select it. Now, in a key sequence program, you can enable or disable a printer. That will be this printer. And then there's also a semiconductor equipment communication systems, RS-232 communication available to connect this electronic control unit to a computer with a serial port configured to use SECS communication protocol. So this system is not included with the PC. Now, if it is enabled, then we can upload the data onto the other computer. Also, the analytical results also can be transmitted if necessary. So I'm going to go to the next menu item, which is automatic program. So once you select and enter, so in this mode, we can program the stage to move to various points, and then we can enable the key sequence program numbers at that point, and then we can scan. That means more than one locations can be programmed, and as we start programming it, we can locate the stage, and the stage X and Y coordinates will be. So once we enter a program number here, I can select a program 1, and then we can also enter a lot data if there is a desired lot number is available, and then any wafer serial number, if it is there, we can enter it, and then we can copy from a previously entered program by locating it at the copy and selecting that number. Now once we are here, there are various function keys available in this system. These function keys are listed in the user manual, and for example, if I say function 99, so this is a help menu, and it displays all the functions available. So we can insert a desk cue point for quick alignment of the stage, and then function 1 is to delete a mode. Function 2 is insert a mode. The mode is the coordinates where we want to scan. And then function 3 is a stage jog mode. When function 3 is selected, we can, by moving by pushing these up and down arrows or left and right keys, we can move the stage to the desired location. And function 4 is the automatic run mode. Once the modes are entered using function 2 key, then we can select function 4 to run the mode. And function 5 is toggle software verticals, and function 6 is semi-automatic run mode, where we can run every step in the automatic program. So function 7 is the stage control parameters. So these are the various functions available. So by pressing down key, we can see some more function keys. So sometimes by selecting function 9.3, this option is not available on this system, but rotate auto theta is possible. And function 9.4 is also to rotate it back to the first location. And there are other function keys available here, but this is retrieve program host when it is connected to a host using 6 communication cable. And then various other modes are also seen here. So the function help menu is helpful at any point of time to refer quickly on the screen while using the system. So press clear to exit. So there's a CLR button here, and we exit. So I'm going to press function 2. Now I have already entered the key sequence programs here, and I can select 0 to 9. So I'm going to select first 1, and then enter. So what the system does is, now it moves the crosshair where you want to locate it. So this will be the beginning of the first scan, and I want to start from the other end. So I'm pressing the right arrow. If you press the right arrow, the stage moves very slowly. So if you press right arrow and fast, the stage moves rapidly. So after selecting a location, we can say enter. So this is the first coordinate from where the scan begins, and the scan length is decided by the program routine selected in the key sequence menu. So I'm going to now select for the second point here. So the cursor automatically moved to the next step, so we can enter key sequence 2 because I have already programmed it, and then press enter, and now we can move it to another point and just press enter. And I'm going to add one more point just to select, and I also have a key sequence 3 program already entered, so I'm going to enter it and then locate. This time we'll move it in x-axis. And say enter. Now when we want to stop entering the mode, so we have to enter 0 as the key sequence. So once you enter that and enter it, so that's the end of the entering the data for the modes. And now we go to the first step in the sequence. So we can enter at any mode or enter there. I'm just toggling between the video modes so that I can display the graphics better. So once you are on the first mode, then if you press function 4. So what the stage does is it goes to the first coordinates, first points entered, and then it will start lowering the stylus. When initially the stylus arm is lowered, it goes down very slowly, and please wait is indicated on the screen. And I want to show that there is a lamp illumination facility knob here, adjustment knob here available. And also we can by this knob, by pushing in and pushing out, we can zoom in and zoom out like that. So I'm pushing in, it zooms in, by pulling it out, it zooms out. So there is a separate DC power supply connected to this zoom in thing, which needs to be plugged into the 110 volts. So I will label it focus knob power. Now here the scan length is going to be 1315 microns. So this is the second step entered in the program. So we can see now it moved to the third step. So with one single key switch, function 4, the auto mode operation begins. So since I have a very small sample here, which has about 4,000 angstroms set on it, 4,500, and I'm just demonstrating that the auto program works on it. So this time the scan length is 1,800 micrometers. Now you can notice it, the initial scan has an angle tilt on it, and it can be leveled. So that's the end of the profiling of the 3 locations. And I did not enable the printer, but if we enable the printer in the program, it will print every profile, and the print will be available on this thermal printer. Now I'm going to show how to do the step height measurement on this, and I'm going to select a manual program instead of an auto program. So for that I will go to the scan program menu and enter, and I'm going to select program 1 for demonstration purpose. Now here, if we just press this up or down button, the blue button here, up and down arrows, what happens is the stylus arm comes down. At no point of time this shield on the front of the stylus should be taken out. This has to stay mounted in like that, and that protects the stylus from falling down. And people assume that has to come out, but not on this particular Dektak 3030 profile. See, the stylus is down now, and you can see the hourglass image, the mirror image of the stylus tip, and then it exactly shows where it is located. So I pressed function 9.7 and I got the cursor. So by using this knob, we can move the location of the image with respect to the cursor. So what I'm doing is I'm aligning the reticle. I'm making the crosshair match with the tip touching point, so that I know every time where it touches, and then I press enter. So now my stylus contact point is aligned with the reticle. So now once it is done, we can reduce the illumination so that we can see the graphics, and then we have a program already entered. So Now the cursor, reference cursor is at 100 microns and measurement cursor is at 900 microns, and my scan length is only 1 millimeter in length. So I'm just pressing scan while the stylus is still touching the surface. Now at this point we see a rough scan. It is pretty much horizontal. So there's some vibrations in it. At the beginning we can see the Armstrong level. So let us scan it one more time. So this surface profiler requires a very clean surface, clean of any particulate or dust or even greasy layer on the sample. Clean samples give a better profile. So it's a clean profile here and pretty much horizontal. So I'm going to show the graphics and adjust the reference and cursor. So in order to move the reference cursor, press the reference button and move the cursor closer to the step. So this is our step here. And then press the measure button and move it closer. And now we know approximately the cursor is within 50 microns of the step. So now we press level. So it will replot the profile with using those points as zero level. And sometimes it is also possible to zero the level too, so it will replot again. Now the user's manual suggests in order to have a step height measurement, we have to have the cursors within 20 microns of the center of the step. So for that, we have to first move the measure cursor closer to the step and reference cursor closer to the step, and then we can replot the whole graph by adjusting the left and right limits. Also top and bottom limits can be moved. So you press left and move the left and right arrows. Now I'm pressing right and moving the right limit. So what it will do is, it is like I'm going to zoom in on the zone which is selected by the left and right limits. I'm going to show the bottom limit as well and top limit. So we just brought it down. So we have to then plus replot. So here is the step. So very clean step. And now, just to get to the point, this is the midpoint, which is displayed here, reference cursor at 294. So 294, and now I'm going to position the measure cursor within 20 microns of that. So at about 314. And then now move the reference cursor to 274. So once we have positioned them, then we press average step height, that is ASH. Now we got the average step height as 4,613 angstroms, or 461 nanometers. So we are measuring with the reference at a zero level and the measurement cursor at the desired distance away from the zero level and measuring the height. So depending on the scan length and depending on the scan speed, the profile will slightly differ in the angstroms, and the manufacturer's specifications and accuracies are listed, and this system can detect the step height differences in tenths of nanometers or in angstroms. And always it is important to note that the step height is dependent on the ambient environment. The system should be located on a sturdy, stable, and any vibration sources such as compressors or cooling fans, which are not on this machine at all. Everything, this tower is convection air cooled, and there's no cooling fan in any of these electronic modules currently. So in case if there's a PC or anything on the same table, please isolate it. Or there's a built-in isolation table under this profiler, and those are just isolation, spring-loaded isolation modules, and there are 4 of them. And when we ship it, we lock them from the bottom of this stage. And then when you actually, before installing the system, those screws should be unlocked so that the system will be isolated from the ambient vibrations. Now various other parameters such as area can be selected. It is giving us the area within the boundaries here. And maximum height, it is telling us what is the maximum height it is detecting. And this is another parameter, or A. So smoothing effect is asking us in angstroms or whatever. So it also displays in the graphics the location of the right cursor and location of the measurement cursor at any point of time, and it's very helpful to have those values. So I'm going to select function 3, and then locate the stage, in a different location. And now I'm going to see, I pressed video and I got the location of the contact point coordinates. So we have to be to the left. The cursor should be always to the left of its step height. So now we're going to scan here, so I'm going to press scan. So every time you press the scan, the grid appears, and now the stylus is being lowered slowly. Unfortunately, the automatic program cannot be saved on it because it is only possible to save the desired program in a host computer and retrieve it. So every time you load a sample and unless you power off the system, the program stays on. And during normal operation, when the stage is when the system is not being used, you can either lower the brightness here, and also the lamp intensity can be reduced so that the cathode ray tube won't be burned. It's a very old monitor, so leaving it fully in the bright display and contrast, there's a danger of the graphics burning into the phosphor when you leave it on for extended period of durations. So now once I profiled it, I'm going to level it, and then just for the quick measurement, I'm going to, without going into the, so I want to print this. Just to print it, you just press print. So this is a print of the screen. Everything we have here is being printed. Now when you want to zoom into the screen and so that you have more detailed view of this profile, so you replot. Now we can locate the reference and measurement cursors close to where you want it, and then you press arrow step height, so the height is displayed, and you print, so you get the screen print again, and this time you will also be having the step height value printed as well. So only a hard copy is possible, or if you have a video camera, you can take a screen image and use it later just for records. So all the connectors, interconnections between the tower and the profiler will be labeled, and they are very easy to connect. So here's a cable for the monitor from the tower, and there's a camera signal coming in, and the printer cable. All these connectors are well labeled and marked. The scan head connector. So at no point of time these cables should be loose from the connectors. It should be secured using the screws. The sample and demonstrate how it scans. You can see a lot of scan scratches on the sample, but I'm going to select a location where it is clean.
Eric Smith, call on line 1.
So if you don't press the fast button, then it will jog in very slow steps. The small steps are very tiny little, of the order of few microns. Okay, now that we have established the location of the scan, so I'm going to lift up the stylus and going to select scan and the video. And every time the stylus tip touches the sample, it appears to move to the left, and it is normal. So the profile appears to be tilted, which is of the order of few thousandths of kiloangstroms. So in order to level the profile, there's a big Z knob available in the front. By touching it with your finger, if you would rotate the Z knob in clockwise, it will start to change the angle of profile. Let me demonstrate it right now. So if you rotate it clockwise, the knob, then it will go up. And if you rotate it counterclockwise, it will go down. So let's see. So before, every time a sample is changed, depending on the parallelity or the surface of the sample, the Z knob need to be adjusted a couple of times. Once you establish that the profile is flat enough, it gives a better measure. Even if it is not, still the step height will be measured pretty close to the exact value. The desired height will be same whether the profile plot is horizontal or slightly tilted, unless the end of the profile goes beyond the visible zone. So let me level this. So the average height here is about 9,000 angstroms, and which is pretty close to what it should be. Now also there is a provision on this system that is to calibrate the step height. So at any point of time, if it is desired to calibrate it to match the actual measured value to the desired. So when you have a standard, a step height standard, you can always press function 0 and you can enter the expected value here from the NIST traceability value of that step height, and you can replot it and it will show the height that is entered. So the software calibration will permit only to enter the values close to or under 5% of the measured value, and in case a hardware amplification or gain is desired, so that need to be done on the electronic board on the back side of this system, and which is only recommended for the trained operators on this system. I'm going to show which path to be adjusted just in case if it is needed, because it is important to note that this system can profile up to 20 micron step height. So this is the path which is R99, which could be adjusted to increase the gain, step height gain of the system. Now that is to be done if software height calibration is not possible. So usually a couple of standards have to be kept handy to have the unit properly calibrated to measure the unknown values. So within the range of the unknown values, if we have standards, and it will be better to get accurate measurements of the unknown samples. So this system is pretty simple and easy to operate, and at any point of time, if you want to change the angle theta, you can use this micrometer here. the system is not having an auto data, which is possible to upgrade it by connecting proper control signal here. So all it does in auto data is rotate it by 180 degrees, and thereby you can locate the sample at the other half of it. And also the X and Y 00 coordinates are not at the center of the chuck, and it is very important because the stylus arm can only move front to back. So all it does is it is actually, the arm is stable, but the stage goes front to back to scan it. So, and then it's possible to locate on a 6-inch wafer in the desired location by adjusting the X and Y coordinates where the stylus will touch the sample. So I'm selecting the printer option for printing in the sequence program 2, and I'm going to show how it works. So I'm going back to my auto program and enter. The program is still there. So the key sequence program 2 is selected in the second mode, and that's where it's going to print. So let's say function 4.
John C. Crow, come to the office.
So this is the first location of the scan, where the program number is 1, scan length is 1 millimeter. So it's a pretty rough sample though. Whoa. There's a big dirt on it. Just for demonstration purpose. Now we're going to the second point here. So while scanning, no attempt should be made to touch anything on the table, because the stylus is very sensitive to the vibrations, and now it is printing. So that's how we enable the printer. So just I'm demonstrating how it can work. So if I want to stop it at any point, press scan again, we can just stop the scan. So that is an easy provision available here. So I'm going to select scan program again and select program 1. Yes. So wherever you want to be, if you want to take one measurement, select scan program and do it. Raise the stage up, rotate the knob slowly, and the stylus arm will go up. Now I'm going to remove the stage. That's why I'm raising the stylus arm to the maximum possible. Do not rotate it and keep rotating when you hear a click sound, because the belt starts to slip once it reaches the end. Now I took the sample out and I'm going to power up the system, because I'm going to power off it and then show you what screw to be. There's a rack screw which has to be accessed from there. Can you see my tip of my screwdriver there? So that rack screw, you have to rotate it clockwise so that the gear will be disengaged. So when you want to engage it, you have to rotate it counterclockwise again. Once you disengage it, the stage will slide out like that. Then you disconnect these connectors. So this is a vacuum line, and this is for the theta motor. And currently there is no power going to the theta motor rotation, but there is a motor on this system. So once you do that, lift it up and slowly slide out the stage. So this is the stage, and the installation of the stage also is to be done very slowly without damaging the Teflon pads here. So these pads are the main things, because it slides against these Teflon pads. That's why we get a smooth scan one. So located on a flat surface. So the stage, so this is the screw. To engage it, if you rotate it counterclockwise, that's when the arm gets engaged, the geared wheel gets engaged to the scan arm. Load the stage. So first, you make sure this arm goes through the slot there, and have to do it very carefully. And then we have to make sure these clamps are pressed against the sidewall instead of sitting on it. So it will be easy loading if you take out the shield also sometimes. And this is just for demonstration purpose, but you should be able to locate it without removing it. That's how it goes. So you place it in, and you reach out to that flat blade rack screw and rotate it counterclockwise. So if you are not engaged, then it will move freely, but once you rotate it counterclockwise, only the motor can move it. So now it is engaged. The ribbon cable for the stage motor and the other two lines. All right. Just to show. See, that sound is, the stage is being driven inside to the initialization condition, and we have to lower this, we have to place a sample, and then any time whenever you you take out the stage, you have to make sure that you're able to see the sample and the crosshair location. So when you first press any button, the program or up-down button, the stage motor initializes. So it locates it to the end and goes back to X0 and Y0 coordinates. So this has to be kept in mind because the stage movement will be rapid during the initialization, and if you don't pay attention, then so you can see the stylus coming down, and you have to make sure that function 97 So I was in the program. Okay. So the monitor brightness can be adjusted from here, and the image brightness can be changed by adjusting the lamp intensity. So usually the printer is placed on the top of this monitor, and the cover exists for that, or it can be placed adjacent to the system.